Good afternoon, guys. Today we're going to continue looking at rational expressions, and in this session we're going to deal with rational exponents. Before we get started, there's three little rules or definitions that we need to know. The first one is that a to the 1 over nth power, well, that can be written as the nth power of a. The second one is kind of an extenuation of this one, but a to the m over nth power is equal to the nth root of a raised to the m power. And then the last one is if I have a to the negative m over n, well, that's the same as having 1 over a to the m over nth power. And then we already know what this goes to. So this is 1 over the nth root of a raised to the m power. All right, so these are our three rules, our three definitions we're going to follow as we start trying to simplify some of these rational expressions that have rational exponents. All right, so let's look at some. So my first one, I have 169 raised to the 1/2 power. All right, so we're following this one. So according to this, whatever your n is, whatever your bottom number of your rational exponent is, well, that's the root that we're going to take. So here I'm taking the square root of 169. All right, and if you know the square root of 169, you'll know that it's 13. If you don't, then we're going to see later on how you can solve that out. All right, let's look at another. So I want the 16 to the 1/4 power. Again, we're going to follow this top one. So it tells me I want the fourth root. I want the fourth root of 16. So what number times itself 4 times gives me 16? Well, our answer would be 2. 2 times 2 times 2 times 2. That does give me 16. All right, let's look at one more. So we have negative 27 raised to the 1/3 power. Again, following the first rule, we have the cube root of negative 27. Well, remember from our last video, it's okay to have a negative under the root as long as we have an odd index. So what number times itself 3 times gives me negative 27? In this case, our answer would be negative 3. Negative 3 times negative 3 is positive 9, times another negative 3 is indeed negative 27. All right, good. Let's try to get a little harder now. All right, now we have 81 raised to the 3/4 power. All right, so now we're following our second rule here. So what it says to do is we want the fourth root of 81, and then we want to cube that. So I want the fourth root of 81, and then I want to cube it. All right, well, if you don't know the fourth root of 81, we can figure it out by solving simplifying rational expressions in our last video, the way that we did that. I'm going to find the prime factorization of 81. So that's 9 times 9. This is 3 times 3. 3 times 3. And so we can rewrite 81 as 3 times 3 times 3 times 3. So now that my index is 4, it tells me I need 1, 2, 3, 4 of a number to be able to pull 1 out. So I have 4 3s. I'm not left with any more. So I just have a 3, but remember, our answer has to be cubed. So we're looking for 3 cubed. 3 times 3 times 3 is 27. So 81 to the 3/4 power is equal to 27. All right, let's look at one more of these. So we have 64 raised to the negative 3/2. 64 raised to the negative 3/2. Now we're on this last one here. Okay. Well, in order to make it positive, we just flip it. Okay, flip it, put it under 1. So I have 1 over 64 raised to the 3/2 power. All right, now we can apply this second rule again to this one to figure out the bottom. So I have 1 over the square root of 64 cubed. All right, so the square root of 64, and then my answer needs to be cubed. All right, well, the square root of 64, we already know that that's 8. So now I just want 8 cubed. All right, so what that means is we want 1 over 8 times 8 times 8. All right, well, 8 times 8 is 64. 64 times 8. Let's come over here and do the math. That's 32. 6, that's 48 plus 3 is 51. So our answer simplifies to 1 over 512. All right, so that's the beginning of simplifying rational expressions that have rational exponents. All right, so we convert them using our definitions and then simplify. All right, so now what we're going to look at is simplifying expressions with rational exponents using our exponent rules that we learned earlier. So now we want to simplify expressions, all right, that have rational exponents. All right, so let's look here. So first we have 3 raised to the 1/2 power times 3 raised to the 3/2 power. All right, well, if we remember back to our exponent rules, if we have the same base, all we have to do with our exponents are add them together. So really we have 3 raised to the 1/2 plus 3/2 power, which gives me 3 to the 4/2 power, which is 3 squared. And what is 3 squared? 3 squared is 9. So 3 raised to the 1/2 power times 3 to the 3/2 power is equal to 9. All right, good. Let's try one more of those. I have y to the 7/3 power times y to the -4/3 power. Again, we have the same basis, so we just add our exponents. So we want y 7/3 minus 4/3. Well, 7/4 is just 3, so y to the 3/3 power, which just reduces to 1, and then y to the first power is just y. So it's y to the 7/3 times y to the -4/3 power simplifies to just give us y. All right, very good. Let's look at a different kind of those now. All right, so here we have k raised to the 1/3 power over k to the 2/3 times k to the -1 power, -1 power. All right, the first thing we want to do is we want to combine the bottoms. So I have to add these two fractions together. So that's like having k to the 1/3 on top over k to the 2/3. Well, I need to get common denominator, so I'm going to write this as -3/3. That's the same thing as -1. Again, we haven't changed the value of anything. All right, we'll now add 2/3 to -3/3. My top stays the same. On the bottom, I'm left with k to the -1/3. Well, now we have the quotient rule, which tells us we need to subtract our exponent. So I have k to the 1/3 minus a -1/3. Remember, minus and negative turns positive. So I have 1/3 plus 1/3. So we get k raised to the 2/3 power. So we're just following our exponent rules, working the same way. All right, just because it's a rational exponent, don't let it scare you. Be confident that you know your exponent rules and properties, and just apply those as need be. All right, so one more of these just to make sure we got it. We have x to the 2/3 power squared over x squared raised to the 7/3 power. All right, so here we have the power of product rule, which first tells me if I have a variable raised to an exponent, I multiply. So right off the bat, this gives me x to the 4/3 power over x to the 14 over 3 power. Well, now we're back to right here. All we have to do is subtract our exponents. So I get x to the 4/3 minus 14 over 3, which gives me x to the negative 10 over 3. All right, but remember, we don't want negative exponents, so to make it positive, we have to flip it. So flipping this gives me 1 over x to the 10 over 3rd power. All right, so you really want to make sure you're up to date on your exponent rules and know how to apply them to these problems.